he will give us an insight into the security of robotics and AV. Chandrasekhar Gale has got a professional experience of 8 years in ADAS and AD projects. He worked with the Continental Corporation, KPIT Technologies, etc., for various automotive projects. He is an experienced senior engineer with a demonstrated history of working in the autonomous driving and related areas. He is skilled in robot operating system, closed loop simulation, MATLAB, CarMaker, and C++. And he is currently working on the development of closed loop simulation tool using FMUs and ROS. I am quite sure that he has got a complete knowledge of autonomous driving, software architecture, simulation scenario development, ROS2 development, simulation test case development, etc. And I hope he is the right person to explain about the security in robotics and the autonomous vehicles. With this information, I would like to invite Chandrasekhar to handle this present session. Thank you.
Thank you, sir. Hello everyone. Good morning. I'm Chandrasekhar, and I am working with Great Wall Motors. Please confirm if you are able to hear me well and clear.
Yes, yes.
Yes, sir.
All
Clear.
right. Okay. Okay. So today let us discuss something about security of robots, robotics, and autonomous vehicles. We are currently working on autonomous vehicles project here at our company, and we are considering various aspects of securities and security breach that can happen with respect to the autonomous vehicles. I guess we can start discussion about autonomous vehicles. Then I would like to explain something about drive-by-wire technology, and later point of time we can discuss something about communication channels that are associated with autonomous vehicles. Then we will understand what are unmanned aerial vehicles, then possible goals of hacking into autonomous vehicles. Then we will understand what and all are the factors that can lead to the vulnerabilities of our autonomous systems. Then we can understand the key attack vectors, then followed by risks associated with autonomous vehicles, the key impact areas. Then we will understand some standards which are followed in the industry to have some kind of security insurance along with the autonomous vehicles. Then we will understand what and all are the overviews and development processes that are followed. And finally, we will understand what and all key principles that can industry follow so that we have a safe and secure autonomous vehicles. Okay, so now this is a new era of autonomy, and this situation, like we are surrounded by several automated vehicles, several automated robots, we can say. We have unmanned vehicles that are nothing but the drones and some automatic flying machines. Then we are surrounded by um, semi-driverless cars, not perfectly driverless, but now we are heading towards the generation of autonomous and driverless vehicles. Then we have got the Internet of Things, several connected components are there, and there are also industrial robots and all. So we are heading towards a era where everything is automated, and we are going towards lower and lower manual control of any any systems, we can say. So maybe today we can focus more into security of autonomous vehicles, UAVs, and some autonomous robots. And that there are some classifications of autonomous systems. So anybody know these levels of autonomous vehicles? Okay. So I'll explain how it looks like. So it starts from level 1 through level 5. And we can also consider level 0. Level 0 is nothing but there is no automation at all in terms of a vehicle, for example. So the early vehicles where everybody used to drive manually, and there was no automated control of any component of the vehicle. So that is what we consider a completely manual vehicle. So after that, there are several levels: level 1, level 2, level 3, level 4, and 5. So level 1 starts with a very basic control of the vehicle, automated control of the vehicle. We can say automated braking of a vehicle, then lane keeping, keeping the vehicle in a one particular lane, then emergency braking whenever there is a some kind of obstacle in front of the vehicle, then vehicle will automatically brake. So this is a very basic level of automation where only certain component or certain part of the vehicle is controlled by automation. So after that, there comes the second level. So there we can say that vehicle steering is controlled by ECU, for example. Then lane changing, that is not the automated lane changing, but whenever a driver has the intention, then there will be a support from the vehicle for changing of a lane. And then after the traffic jam assist. So these kind of features can be considered into level 2 features, and these are altogether can be called as advanced driver assistance system features. So this is nothing but those features are developing the supporting the driver to control the vehicle. So it is not a complete control, but it is nothing but a partial control of the vehicle or some component of the vehicle. So after that, there is the next stage, that is nothing but the autonomous, completely automated vehicle. So in that one also, like there are certain levels, and there again it comes the level of control. So level 3, level 4, and level 5. So level 3 and level 4 are nothing but highly automated vehicles. So where the steering as well as the braking of the vehicle is controlled by software. And then automatic parking of the vehicle. Let's say some user is in front of some parking area and he wants to give his vehicle for parking, so he can initiate that with the help of some mobile application or something. So where vehicle will automatically drive into the parking lot, and it will find out the available space to park the vehicle. And so that's what we call it as level 3 and level 4 of automation. And finally, the fully automated vehicle, that's what we are focusing on. So those are nothing but the completely autonomous vehicles where a driver will not have any kind of control, but maybe some users will have only control of giving the destination or some kind of other inputs to the vehicle. But the driving aspect, there will be no control from the driver side. Everything will be controlled from the software itself. So these are all the levels of autonomy. And so as we are going towards the autonomy, so there comes several risk and some kind of possible threats associated with the vehicle, and there can be some threats to the environment as well. So that's what we are going to study in today's session. So yeah, so as I mentioned earlier, that ADAS that gives us the partial vehicles control, and some components of the vehicle and some parts of the vehicle are controlled in case of the ADAS systems. So the examples are cruise control, adaptive cruise control, traffic jam assist, hill hold control, lateral control function, emergency braking assist, highway chauffeur. So I guess everybody might be aware of these terminologies. So in case if someone is not aware, the cruise control is nothing but vehicle. So whenever someone is on highway, so they just have to enable some function that will automatically control the vehicle's speed, and it will keep following the lane. And if there is any curvature of the road, then steering will automatically adjust so that the vehicle will remain on the road. Okay, so after that, we have got traffic jam assist that will assist the driver to crawl the vehicle in the jammed road conditions, for example. So let's say we are stuck in traffic, and the traffic is moving at some 5 kilometer per hour speed, and the driver will have to continuously press clutch pedal and brake pedal. So that can be taken care by the traffic jam message feature, and the driver has to just enable that feature and he has to relax, and vehicle will automatically keep following the traffic. And after that latter function, so that will enable the driver to automatically change the lane. So driver just have to give the left or right hand indicators, and automatically will vehicle will change the lane whenever that function is active. Then after the brake assist in, so whenever there is any obstacle in front of the vehicle or any pedestrian comes accidentally in front of the vehicle, then vehicle will automatically apply the brakes, even though driver may or may not apply the brakes. And then there is a highway chauffeur function. So these are all the partially controlled features. So after that, let us understand the ADS features. Okay, so before I move on to further slides, please feel free to ask me any questions or doubts if you have any, and I'll be happy to answer. Okay, so let us understand the architecture of autonomous vehicles. So so you might be aware that every vehicle needs some kind of sensors so that it will understand where exactly it is, what is the situation, what is the road condition, what is the environment around the vehicle, right? So for that purpose, every vehicle, the autonomous vehicles in particular, will have several different sensors, and those sensors will gather some raw information, and those that information can be processed with the help of some modules, and then based upon that information vehicle will make some decisions how it has to perform the condition and traffic condition. And then once the decisions are taken, then after there will be some control or activation modules in the vehicle that will lead the vehicle in that particular direction and in that particular maneuver. So the examples of sensors are nothing but the GPS sensor that will allow the vehicle to locate on the part of the world. IMU sensor is there, lidar sensor is there, camera sensor is there, radar sensor is there. So all these sensors has to be kept on the vehicle so that we can get the clear understanding that how vehicle is situated and what is the road condition. Then after the sense part comes into the picture, there are several modules in autonomous vehicle software stack. So localization module that will identify where exactly is the vehicle, and mapping module is there that will download and that will fetch the road condition. For example, if our vehicle is at some particular road, and so there is a, stored database of that particular road, and there like everything is mapped. For example, how many number of lanes are there on that particular road, and where is the exit lane, where is the entry lane, for example. And all these things are recorded in a HD map, I would say. So in case if you are not aware, the standard maps are nothing but where we just only get the traffic information and road information, but there is an advanced level of maps where we get everything, even the number of lanes, the traffic signs and all, the legal speed limit on the road, the entry lane, exit lane, all those things we can get it from the HD map. So vehicle will always have the database of the HD map, and it will interact with the HD map, and it will keep understanding where exactly it is and what is the current road condition. Then there are other modules, kind of perception and prediction modules. So these modules are based upon the camera information and radar and lidar information. So these modules will identify what are the obstacles in front of the vehicle, and what is the road scenario, and if there is any particular kind of a road, let's say country road or a highway or something like that. So all these kind of understandings will be so these information can be achieved with the help of the perception and prediction module. So from these modules, the data goes back to the planning part of the autonomous vehicle software. So there are several modules which will make the planning, and there is a trajectory planning module that will decide which trajectory a vehicle has to follow. Then route planning module is there. So based upon the location of the vehicle and the target destination, it will identify the best possible route that has to be followed by the vehicle so that it can reach its destination in shortest time period and shortest distance traveled. Then there is a motion planning module, so it will keep track of the front vehicles, and it will decide the what is the best speed of the vehicle that has to be kept so that it will not go and crash into the oncoming traffic and all. And there is also behavior planning module. So these are all the modules that will ensure that the vehicle is following the correct track and it is following the safe trajectory. And then there are activation or control modules in the vehicle. So motion control module is there, actuator control module is there. So uh, these modules will sorry, I'm so sorry. These modules will give the control to the vehicle. So the steering angle and all, the amount of acceleration and all, so all these things are controlled by the act part of the software stack. Okay. So coming to the next slide, the drive-by-wire technology. So as you all aware that now it is a autonomous or assisted driving era. So earlier in old times, we used to have the manual vehicles where everything was controlled manually. So let's say the power windows of the vehicle. So earlier, like we used to have a rotating handle, we had to roll the handle, and that used to roll the window. So something like that. So, but today's technology is nothing but the drive-by-wire technology, where everything is controlled with the help of some electrical connections. So let's say if we are turning a steering, in old times we had to apply a lot of pressure on the steering wheel. So then only vehicle used to move, steering, the tires used to move. But today we have got electric power steering that will just driver has to apply small pressure on the steering wheel, and everything is controlled. And there will be some actuator motor which will control the steering angle. So something like that. So there are like many modules in the vehicle which are controlled by wire. So that is what we something call it as drive by wire feature. Okay. So next thing is the communication that is happening in aspect of the autonomous vehicle or any automated robot, we also can say. So so there is a vehicle, and then that communicates with many different entities. For example, so vehicle communicates with satellite to get the GPS information. Then vehicle also has to communicate with the mobile so that we can control the vehicle with the help of mobile applications. So you might be aware that with some high-end vehicles and all, and even with some newly launched vehicles like Kia Motors. So we have got several features that can be controlled with the help of mobile application. And then after we have vehicle has to communicate with the cloud server as well. So and then after vehicle has to communicate with some infrastructure as well. So these are all the communications that are happening associated with the autonomous vehicles. And so these are all the um, areas where any kind of intrusion can happen. So these are all the communication channels that we have to consider. Okay, before I move on to next slide, can you confirm like if everything you are able to hear it well? I just want to confirm it once again. Hello.
Yes, sir, it's quite audible and good.
Okay, great, nice. Okay, so yeah, so as I discussed about app-based vehicle control, so that is something like we can start the engine of the vehicle, we can start the air conditioning system of the vehicle, we can make the parking of the vehicle from the parking lot, we can park the vehicle. Along with that, we can also take it back from the parking lot. So these are several app-based vehicle control operations that can be done with with autonomous vehicles. So after that, we also have the over the air updates. So that is also one more aspect of autonomous and assisted vehicles. So you might be aware that for our mobile phones we get the online firmware. So like many times what happens is we get the notification that there is a new update available for mobile software. So similar way, like nowadays the new vehicles are coming with a feature called over the air updates, so that like we can get the new software for the vehicle that will control the infrastructure of the vehicle in a better way, and that will improve the vehicle's performance as well. So one example is Tata Nexon electrical vehicle EV. So that has got some OTA updates, and so many users commented that once they got the new update, the latest update from the workshop, then they saw that the battery performance, it's a electrical vehicle, so they understood that their vehicle is giving a better mileage when the vehicle is charged. So something like that. So this is a new generation where we can see that like the mobile smartphones, there will be over there updates for the vehicle. So like right now every user has to take their vehicle to the workshop, and their vehicle's new firmware is updated. But in the future it may not be surprise for us that even like our vehicle is parked in front of our gate, and it receives some kind of update, and once the update is done, then we are ready to use the vehicle. So this kind of update can be done, and this software update can be done based upon the cloud, and the company from where it will occur, the OEM, vehicle manufacturer companies, they will come across with several new features, and then they will launch those features based upon some software update firm, or some kind of online update technology, something like that. So so these are nothing but the OTA updates. Then there is the next feature is connected diagnostics. So nowadays what happens is whenever we are driving our vehicle, let's say some kind of breakdown happens. Normally what we do is we try to contact like some local mechanic or something, like who will come and who will try to uh, who will try to repair the vehicle. Or some users, what they do is they have to call the service center, and then the service center people, they will come and they will see what is the problem with the vehicle. They will sometimes tow the vehicle to the workshop, and they will repair the vehicle, something like that. But nowadays, like in the recent in the latest era, like we don't have any feature to identify what and all are the issues, or some kind of warnings associated with the vehicle. We can see the information on the dashboard that let's say engine temperature is high, something like that. But now we are heading towards some technology where vehicle will automatically log the errors or warnings on a cloud server, and then based upon that there will be a technology center. They will analyze like what is the issues with the vehicle in case there is a breakdown of the vehicle on the road. Hello. Okay. Yeah. So something like that. So even the users also can get the information on their mobile smartphone that there may some kind of trouble with the vehicle, and there are some kind of warnings that has to be taken care of. And now we can also expect that tomorrow, in case there is any breakdown of the vehicle, and then after what happens is like we just have to contact the service center. They will get the details of the vehicle immediately based upon this vehicle's communication with the cloud center, and then they will identify the root cause of the breakdown. They will send a dispatch technician, and he will come to the place, and he will do the right things with the vehicle. So that's how like we are looking towards the connected diagnostics features of the autonomous vehicles and all. Then after some of the features are associated with ADAS ADAS part as well, not only confined to autonomous vehicles, but these can be along with our regular vehicles as well. So here also, like there are several things which are coming into the picture when we talk about cyber security. Like vehicle is communicating with the cloud server and all. So there also, like there are some threats that has to be considered. So then there's the next part, that is nothing but the automatic toll payment. So here what happens is, like whenever a vehicle is running on the highway and there is a toll center, so the payments are happening automatically. Like we have got a mandatory fast tag compulsion from the government, so something like that. So even like some manufacturers, they are considering that they will give this kind of feature in semi autonomous vehicles as well. One of the example was General Motors Super Cruise. So that feature was developed by General Motors, and they launched one vehicle in 2018. And so there it was like it was a semi-autonomous feature. So vehicle used to run on the road, and as soon as it come across some toll plaza, it used to automatically make the payment, and it used to pass through the plaza without any stoppage of the vehicle. So even like here also there comes some kind of financial transactions, and we have to consider what and all are different risks that are associated with automated toll payments. And then after one of the popular example is nothing but autonomous ride hailing service. So many OEMs and many manufacturers, they are looking towards automated taxi services. So user has to book some kind of a taxi, and like it will give the source and destination, and then the taxi will arrive at user's place, and then after he has to board the vehicle, and then the taxi will drop him to a particular location. So this is what we call it as autonomous ride hailing service. And you might be aware that Zoom, the one company is there, owned by Amazon, and they have launched one robo taxi. And so this taxi doesn't have any controls, the steering and clutch pedal and all. So there are no controls at all in the vehicle, so it's completely electrical and autonomous. So users will have to book the ride, and it will take the users to a certain destination. So here also, like so many aspects are there. One thing is, like many users are booking based upon the mobile application. So then after, many are making credit card or something, and those payment details are stored on some kind of database. And so the vehicle is also having some online database to authenticate the correct users, so that it will open the doors for a correct user, something like that. So there are many aspects along with this autonomous ride hailing service. And so there are many possible threats as well, so we have to consider all those aspects. So, okay, let us talk about the applications and use cases of autonomous vehicles. So, there are two parts. One is the military related, and other is the civil related. So, in case of military, like there can be some ammunition delivery or some kind of a cargo delivery. So, like right now, we are based upon the manual driving of the vehicles to deliver some kind of cargo in warfare zone areas. But tomorrow, like we can also look towards automated cargo delivery of ammunitions, I guess. Then after we can also look towards the attack vehicles that can drive into the the enemy countries or something like that, and they can perform the attack missions as the orders are given from the military. And then after we can also look towards the spy missions vehicles. So these vehicles can drive into some border areas where, like, there is a possible threat from the enemies, and then they can carry out some spy missions. So these are all military related applications. And in terms of civil, we can talk about the cargo deliveries in for big delivery companies. Let's say Amazon, they have to send some big package to some remote destination. And in that case also, we can have some autonomous vehicle that will run for some hundreds or thousands of kilometers, and it will go and it will reach the destination, and it will make the delivery of the cargo items. Then autonomous personal vehicles, we can use the vehicles as personal vehicles, and then after the autonomous ride hailing service. So these are all some applications of autonomous vehicles. So moving on to autonomous aerial vehicles. So these are nothing but automated drones or automated flying aircrafts. So this is also one of the newly emerging era of automated control. So earlier, like we used to control the drones and automate flights with the help of some remote controls or something. But like tomorrow, like we can give some mission information, and it will automatically take a takeoff, and it will carry out its mission, and then after it can come back and it can land automatically without having any manual control. Though like today we have got remotely controlled drones and all, and they perform a nice task, and they do whatever the task those are assigned to, and that is going well. But tomorrow, whenever we have got a big number of aerial vehicles, and we have to perform several different tasks, in that case we can also focus towards the autonomous aerial vehicles as well. So here also we can consider how the communication is happening between the unmanned aerial vehicles and the ground control station. So here in this case, the scenario will be something like this. There will be a ground control station which will give the mission information to the autonomous aerial vehicle, and then based upon that information, it has to carry out certain tasks. And during throughout this phase, it will be communicating with the ground control station over some radio signals. It will be also communicating with the ground station over internet and satellite communication. So here also, like there are like several channels over which some kind of intrusion can happen, and we have to also consider what and all are the possible risks associated with it, and how we can take some action, or we can make sure that there is a safety of all these autonomous aerial vehicles. So here also, like there are some applications of aerial vehicles. They can perform the attack missions, they can perform the spy mission, they can perform surveillance, they can perform the they can be used as a targets for training. Hello.
नको थांब मी कल्याण चालायचं. हॅलो
Hello.
हॅलो
Yes, is there any question?
हॅलो आवाज येतोय का? आवाज येतोय?
Hello.
आहे का पण गाडी? हा विचार मग विचार एदर मग त्याला भारी काम होईल, बरं होईल बाई.
I think someone has.
ये ना इकडे धर, त्याला काय
Um,
पैसे देऊ वाटतं.
um, Hello.
Sir, you are audible.
Okay, all right. Yeah, so looks like there was some kind of disturbance. Okay, sorry about that. All right. So where were we? We were talking about the applications of UAVs.
संपला आता. ती म्हणते जिओच्या कार्डवर करते.
Maybe we are the victims of some kind of attack, I guess. Someone is controlling the screen, I guess. I am seeing something, some kind of drawing on.
अरे कुठे बसलीस नाही पण.
Bharti madam. Bharti madam.
हॅलो येतोय का आवाज? आवाज का नाही येत? नाही येते आवाज. थांब, पल्लूच्या ह्याच्यावर करते. पल्लूच्या ह्याच्यावर करते. पल्लू, ए पल्लू, तुझ्या ह्याच्यावर कर ना. माझं ते बहुतेक हे चाललंय ना.
Um, is there someone named Arti or someone? I guess I'm hearing someone's voice, I
Sir, now it
guess.
is muted, sir, please.
Okay, yeah. So there are many users. Okay. Uh, I guess about 82 participants are there. I hope like just I wanted to confirm that we have got the right users, and like we are not getting someone from any other I guess. Okay, all right. So let us continue our discussion about the application of UAVs. So we have got several applications of unmanned aerial vehicles which can perform the attack missions, which can perform the spy missions, which can perform the surveillance of border areas. Then we can also use the aerial vehicles for military training targets. So in order to use them as a target of our rocket launchers or something like that. Then after we can use the UAVs for civil applications for search and rescue operations, cargo delivery, filmmaking, where we can mount the cameras.
कधी पण आज बंद नाहीये ना. नगर किती वाजता जायचंय तुला? उद्या बंद आहे ना. बघ, तुला किती वाजता जायचंय? कोण रवी गेलाय का? गेले की अख्खा दिवसच खाईल. संध्याकाळी 4-5 वाजता.
Sir, okay. So is Arti is a student of TKM or something?
आता 3-4 दिवस बंद. आता मला जायचे आहे. काय पाणी प्यायचं हिला? येणार पाणी ते टोपी आई देते पाणी.
Hello.
आणि बुट काढ, तोंडावर पडल ती. शौर्य,
Hello.
खेळायचंय का? पाणी देते. सोन्याचे दुसरा सोन्याचे. जा नाही येत जा.
Can anyone mute other users?
Only organizer can do that, sir.
Okay.
Firoz sir, if
Yes,
possible,
sir.
can you please?
We cannot, sir.
So is someone there like the organizer or someone, or is it at my control, something like that? If I have to do that.
Sir, if possible, just you can remove her. She may rejoin.
Okay.
पिऊन घे. आणि इकडे तो ग्लास.
Just you can remove her. You have authority to remove. Firoz sir.
Okay.
Please, sir, lot of disturbances are there.
Okay, she is muted, but maybe she's again she's again unmuting, I guess.
There
I
are
guess
few
she has
users,
that
sir.
control.
If it happens once again, we will remove it now. Remove it, sir. Nice.
Okay. Okay, I hope again you are able to see my screen. So let us go ahead with the discussion about the possible goals of hacking the autonomous vehicles. So there can be several a goal or some kind of intention of hacking into autonomous vehicles. So one of the aspect is stealing of data. So whenever we are talking about autonomous vehicles, so these vehicles store a lot of information about their users. So the personal details, name, address, contact number, credit card related information, if we are talking about the autonomous taxi. So that may be one of the intention of hacking into autonomous vehicles. So stealing of data, then after spying and some kind of harassment activities. Uh, so these autonomous vehicles and all, so they are equipped with several cameras and some kind of other audio recording devices and all. So so many people or many some kind of recording things can also happen from the vehicle. So that is one more goal. So then after disruption of service, so someone may intentionally try to stop the service. Let's say one use case is taxi service. So if someone is hacking into that and if he is making the taxis unavailable to any user, so that also may happen. Then after stealing of money, so when we talk about the automated toll payment related transaction or automated billings from the autonomous taxi, so there also we come across several payment gateways and all. So there also someone's intention may be like to steal the money from the users. Then unauthorized access or use of services. So if someone who is not willing to pay but simply wants to use the services of autonomous vehicles, so they also can get into the system and they can try to gain the access of the vehicle and they can try to utilize the services without making any payments or something, or unauthorized use, we can say. And then after the last motive maybe that can be with respect to the sabotage or something like that, or harming the passengers. So the hackers, they can get control of the vehicle, they can control. And as you are aware that nowadays like vehicles are controlled by wires, so everything is controlled with the help of some ECU. And once they got the control of the vehicle, they can give inputs for steering, they can control the speed of the vehicle and all. And that way they can cause some kind of harm for the passengers as well as the environment. So these are all the possible goals of hacking into the UVs. Then comes the goals of hacking the UAVs, the unmanned aerial vehicles. So there can be some kind of attempt to crash the UAV or landing at their own will. Or sometimes like they can also get the sensor data from the UAV into their own servers, something like that. They can get the files associated with the server, and they can also try to control the flight path, and they can direct the flight in some other direction, something like that. So these are all some possible goals of hacking into the UAVs. Okay, so now it comes we have to consider what and all factors that can contribute to having the vulnerabilities in the system. So there are several aspects actually. One part is the backend systems that can cause the vulnerabilities. Then after incorrect permissions given to the users, so that is also another aspect. So like we have to set the certain levels of authorization for every user. And if there are any incorrections in that, so there that one also can cause a vulnerability. Then malicious code injection, that is also one more aspect. So because of that also, like, system can be vulnerable. Then after lack of internal policies or rules that specify the security requirements. So whenever an OEM is developing a vehicle, autonomous vehicle, so they have to set certain policies and regulations, so that has to be met, so that a vehicle is ensured that it's secure and safe. But sometimes some OEMs may fail to adhere to those policies and regulations, and because of that also, a product may be vulnerable. Then after, the product development tools have inherent bug. Okay, that is also one more aspect. So where the tools used for product development, so those tools also may be having some kind of bugs or something. Because of that also, we can see that the system is vulnerable. Then after some developers they use the open source softwares. So in many software companies and all, many developers, what they do is like sometimes they rely on some third party or open source software components while designing their software. And in those cases also, like if that open source software, we have to also consider what is the reliability of that open source software and whether it is trustworthy or not. And we have to so because of that, like if someone is using insecure or some kind of outdated open source software, so because of that also, like our system can be vulnerable. Then after the lack of quality assurance and testing procedures, so every OEM has to again follow the quality assurance measures, and they have to consider every possible scenario of security breach. And they have to ensure that they have to ensure that adequate laws are there, adequate quality assurance procedures are there, which will ensure that vehicle is safe and everything is safe about it. And if there is any lag, then that also may be one of the contributor to vulnerabilities, we can say. Then after the accidental coding errors, so this everything is developed from the software engineers, and also they have to ensure that they are following the correct coding guidelines and all. And if they are not following any, and if there is any accidental error, so that also may cause vulnerabilities. Then lack of understanding or training on secure coding guidelines. Yeah, so that is also one more aspect. So in automotive companies and all, or any software development companies, so there are certain coding practices the developer has to follow. And if they are not following, and if they are not aware of those coding guidelines, so because of that also they can do some kind of mistakes, and because of that our system can be vulnerable. And then after one more aspect is there, that is most important aspect, that is nothing but pressure to meet the product deadlines. So mm, today it's a cut-knee competition between the OEMs. Many OEMs are working on autonomous vehicles. They are like in hurry to launch their autonomous vehicle. And in this competition, if like they are pressurizing the development team to produce their vehicle as soon as possible, so there is obvious scenario that developers may neglect some kind of a security procedures or something like that. And because of that also, like that can cause a vulnerability in the system. Okay, so after that, the key attack vectors that has to be considered. So those are nothing but the LiDAR and radar systems. So that are vulnerable. Then the servers are there, keyless entry system of the vehicle. Then diagnostic system is there, that also is vulnerable. Then there is a communication from the vehicle with the mobile application. So through that also there can be some kind of intrusion. Then infotainment is also infotainment system that receives a lot of updates from server and all, and it is also communicating with the smartphone over Wi-Fi and Bluetooth. So so that is also vulnerable. Then many vehicles are connected to the internet, so that also will be one more vector. And then after V2X communication is there, Wi-Fi is there, sensors, USB port, Bluetooth, telematics control unit. So these are all the vectors that we can consider. Okay. So then after, so we can also consider what and all are the risk factors that we can look into. So let us start with the origin of the risk, we can say. So sometimes, like every time we cannot consider that a cyber security threat is intentional. Sometimes it can be accidental as well. Sometimes it may be some kind of a natural cause, or sometimes it may be a intentional attack to break into the system. Then there are targets as well. One aspect is the physical target, another aspect is the cyber target, and there can be a combined target as well. Then okay, what will be the impact on the system? So impacts are different. So one part is the destruction of the autonomous vehicles. Then after degradation of the vehicle, let's say some part of the system is broken, and we are not able to access that or something like that. And then after the disruption of the service, then after unexpected behavior. So these are all some kind of impacts that can happen on autonomous vehicles. The external impacts that are nothing but on the users. So the users, the active users and the passive users as well. Then after the impact can happen on the business as well. Then after the impact can happen on the organization as well. Business in the sense, let's say we are talking about a robotic taxi, and if that fails, then obviously business will stop. Then after, if business is stopping, then after it also has an effect on the organization as well. And there comes the reputation of the organization as well. So if there is any security related issues, then obviously people's trust will not be then there on the organization. So these are all the external impacts. Then after, what are the risks? Okay, risks are nothing but there are like several other aspects of the risk. Let's say safety of the passengers or safety of the environment, that can be at risk. The privacy of the users, that can be at the risk. Let's say an unmanned aerial vehicle is having a onboard camera, and if someone else, a third party person, he is using the onboard camera for some kind of a recording or something like that, and that is where like privacy comes at the risk. Then after, confidentiality. So if certain areas of a country are there which are not to be explored by someone else, and so if these UAVs are hacked, and their files are stolen, then that their the confidentiality will be at risk. Then availability of the service. So again, talking about the robotic taxi, if that service is not available, even though it is not occupied, but still it is not available because of some hacking attempts, then that availability is at risk. Then integrity, overall integrity of the system also can be considered at the risk. So these are all the aspects of the risks that we can consider. Okay, so let us also discuss the various types of threats, and let us also consider the violated properties as well. So spoofing is nothing but authenticity of the system is at the violation, and then like someone is trying to hack the system, or he's trying to make use of the system. Then tampering, that affects the integrity of the system. So someone is trying to tamper with the memory network, or some kind of online database files or something. Then after, repudiation, so claiming that okay, someone is doing some kind of unauthorized activity, and then he is not claiming for the responsibility, so something like that. Then information disclosure, that harms the confidentiality of the system. So some kind of info is given to some unauthorized people, or some unauthorized organizations. So that also may be like a violation of confidentiality. Then denial of service. So there comes the violation of availability. So some kind of automated vehicle or machine or a resource, making it unavailable just because of no reason, even though like it is not used by the user or something, but simply it is being unavailable. Let's say if someone is trying to book a taxi, and even though taxi is free, but because of some kind of hacking attempts or something, it is seen as unavailable for the users. So that something we can consider. Then after, elevation of privilege. So some okay, even though like some users are authorized to have some kind of access, but still like they want to have the additional privileges, and then also like and there is a violation of authorization. And then these are all the factors, I guess, we can consider as the threats for the automated vehicles. Okay, so far, are there any questions or something?
Sir, can I ask one question?
Yes.
Sir, you were telling about the spoofing attack. So can we please explain the what kind of attack in spoofing attack?
Yes, yeah. So let us take one
And
example.
sir,
For
what are the
example,
difference between the phishing attack also?
okay. So yeah, so spoofing is nothing but let's say if one user is there who is authorized to use some kind of a system, for example, automated robot taxi. Let us take that one as a use case example. And So if that, let's say I have my mobile application, my credit card information is given over there, I'm able to book the taxi and everything. But if someone else is pretending that he is Mr. Chandrasekhar, for example, and he is trying to make use of that service, and he is trying to utilize my account for booking the taxi or something like that. So that's what I guess we can call it as spoofing activity.
So that means
I hope that
unknowingly
answers.
someone
Mhm.
can access your information.
Yeah, like he is pretending that he is someone else, Mr. X, and he is trying to, like, Mr. X is authorized person, and he is trying to pretend that he is Mr. X, and he is trying to make use of his privileges or his facilities, we can say.
So phishing attack is some kind of such kind of thing. This is just the same kind of thing, or
um, can you repeat once again? You are talking about phishing, you're saying?
phishing attack.
Fishing, okay. Fishing would be little bit different actually. Fishing means that they will try to trap the users into some kind of, some unauthorized activities or something like that. So that is a little bit different from spoofing. I'm sure about that.
Oh, okay, sir. Okay, sir.
Okay. Okay. Uh, okay, so key impact areas where like the impacted areas we can consider are the theft of property. So malicious actors, they can steal the vehicle for personal or financial gain. That is one aspect. Then theft of data, autonomous, as we already discussed, that autonomous vehicles, they capture a lot of data and they store it on the cloud. So personal information is there, payment information is there, and mobile phone number, address, and everything. So that kind of data also can be stolen. Physical destruction and sabotage. So vehicle control can be gained, and the destruction of vehicle can happen. Then invasion of property, some privacy, sorry. So someone can again take the personal information, they can take the recordings, the audio recording, something like that, and that way, like, they can invade into the privacy of some user. Then there are some fraud cases that can happen for insurance related purposes. So these are all the key impacts. Okay. Okay, so till now, like, we were considering what and all the possible threats and risks that are associated with the autonomous vehicles. Now we have to consider that what and all are the measures or policies that we can follow so that our system can be as safe as possible and there will be least amount of security breach in the autonomous vehicles. So for that purpose, like, we don't have much of the standards till date. Like earlier, we use for the vehicle level safety, we were having some standards, but that were only with respect to the local vehicle itself. Like, that was not associated with the cyber security related part. That was only associated with vehicle passenger safety as well as the pedestrian or environment safety. But that with respect to the physical safety, I would say. So now there are several standards that are coming into the picture and development, which are talking about the cyber security of connected and autonomous vehicles. So one of the example is ISO SAE 21434. That's a standard. So that is jointly published by SAE and ISO. And so this standard is a newly emerging standard, and we are expecting that in somewhere in the mid of 2021. And so here, what exactly it says, what has to be done, and like, why we have to use the SAE 2144. So that ensures that all the participants and manufacturers, they have a process that has to support a security by design process. So that is nothing but whenever the vehicle is being designed, so that is secure by the design itself. Then after that, norm is applicable to road vehicles, including all the components and connections and the service. So that is not only associated with the vehicle, but the components of the vehicle and the services of the vehicle. So something like that. So this is the newly emerging standard, and it is talking about the policies that has to be followed, and every manufacturer and the service providers to adhere with these policies regulations. Okay, so risk assessment. Okay, this is also one more important aspect of autonomous vehicle. So we have to perform the risk assessment, and we have to consider every possible aspects of that. So we have to identify the assets and potential damage that can result from the breach of security features. Okay, so one part is the assets which are there, and another part is the potential damage that can happen to the assets, and that is what we have to analyze first. Then after. Uh, we have to analyze the possibilities of several threats, attacks, and vulnerabilities. Then after we have to determine the risk levels based upon the damage scenarios, what and all different kind of scenarios that can happen, and what and all the levels of the risks. Okay. Then we have to take the countermeasures until the remaining risk is acceptable. We have to make sure that the least amount of risk is there, or we are at a zero risk. And we have to also identify that, okay, what and all the are the scenarios and what countermeasures we can take. Then after we can also have the documentation of important steps and parts of the risk assessment process, such as asset list is there, damage scenarios is there, attack reports, risk reports, and all. So we can have some sort of documentation that can be followed, and that can be referred by other users, and that is available to everyone in the system, we can say. Okay, so little brief about ISO SAE 21434 standard that is coming into the picture. So this standard is telling us about the procedure and the overall process that a software company has to follow. So it starts from the concept phase, the concept of product development, then after the actual product development, then after the validation of cybersecurity, the actual production of the vehicle in particular, let's say, then the operations, and then finally the decommissioning of the product. And along with that, parallelly, like overall software security, cyber security management will keep on happening, and then after continuous cyber security activities also and also distributed cybersecurity activities also can happen in the parallel fashion. So this is a little overview of ISO 21434. And so in the center is nothing but the risk assessment method. So there are various methods that can be incorporated while developing the software, and those methods has to be analyzed, and we have to also ensure that based upon that, like, we are following the correct standards, and we are making it as safe as possible, I would say. Okay, so the standards which are there in the industry, those standards, they only tell like what has to be done. Let's say ISO 26262, that's the functional safety standard that is widely used in automotive domain to ensure that there is a safety of the vehicle in aspects of functional safety. Then after we have got our ISO 21434 that tells about cyber security of the vehicles and the infrastructure. So these are the standards, but we have to break down those standards into the processes that every organization has to follow. And then after the processes, from the processes, we have to derive the solution that has to be actually adopted in the development process of the autonomous vehicles and any other component, we can say. This is a three layered process. First one is the standard that tell that what has to be done, processes that tells us how we can do that, and the final solution, like the actual procedure to follow to ensure that we have safety from cyber security related threats. Okay, let us consider the key principles that we can consider. So organizational security and governance at the highest level. So One thing is that everybody has to keep the safety and security at the topmost priority, and so that has to come from the organization's policies itself. Then after security risk assessment and management, including the across the supply chain. Okay, so risk assessment has to be done, and risk management also has to be considered. Then cybersecurity monitoring and incident response, that also has to be in place. So one thing is that there has to be continuous monitoring of cybersecurity related risk and its management. And if there is any incident, then there has to be some certain mechanism to give the response in that situation. Then after, we have to also understand the third party risk, and its management has to be considered. Then okay, so after that, the design of the vehicle is to be safe in depth approach. So right from secure by design, that's what we call it as. So while designing the vehicle itself, like we have to consider safety as the first priority, and that's how like a vehicle should be designed. And after, the storage and transmission has to be as safe and as secure as possible. So whatever the data associated with vehicle, the user data and the sensor data, all those things has to be saved as securely as possible. And the transmission also has to be done as safely as possible. And maybe we can consider some encryption and encoding techniques. And then after, there can be some kind of firewalls that only allow certain users and all. And so all these aspects we can consider. Then the vehicle manufacturers, they have to have several different testing procedures on security functions. So they can consider that the rigorous testing procedures are followed, so that all the possible scenarios are considered, and it is ensured that security is not violated, or it is not breached. Then after, the software components of the vehicle, its security has to be managed throughout the lifetime of the vehicle. And vehicle, okay, so vehicle also should have the design that it has the capability to detect the cyber attacks, and it has ability to respond it appropriately. So that also may be one component of the vehicle software that has to be there in the software architecture of the vehicle. And it should be designed such that it's resilient to cyber attacks. So these are all the principles that can be followed by OEMs and software automotive software development companies, and they have to ensure that there are what and all types of the risks are there, then how we can manage those risks. Then another thing is, they have to develop the vehicle in such a way that it is secure by design itself. Then after, they have to ensure that security breach attempts are monitored, and there is a particular proper incident response to those attempts. Then after, there has to be several testing procedures which are considering the vehicle cyber security aspects. Then this security has to be managed throughout the lifetime of the software. So all these are the principles that can be followed. And then after, like we can say that, okay, we are in a safe environment, something like that. Okay, so that was all about the cybersecurity of autonomous vehicles and unmanned aerial vehicles. And so similar aspects are considered along with the automated robots as well. So there are many other kind of robots which are there in the market and industry. So similar kind of principles that can be applied to those robots as well. Okay, so far, like that was all about the autonomous vehicles and its cyber security. So please let me know if you have any other further questions or something. I'm happy to answer.
Dear participants, if you have any questions, please ask. Participants, please unmute and ask your questions.
Um, okay. So in case if there are no questions, okay. So maybe if someone of any participants, if they have any other doubts or something, like they can feel free to reach me on my mobile number. It's at 38621. Otherwise, you can also contact me over email. It's cghale12@gmail.com. So these are my contact details. I'll be happy actually. I'll be happy if anyone asks me any kind of doubt or something.
So I think there are no queries from the participants.
So
So I think we can wind up the session.
Yeah. So just wanted to conclude my presentation with some message. Okay, so now today we are at risk of coronavirus, so we have to follow some guidelines given by the government. So we have to use the mask, we have to use the sanitizer as much as possible, and we also have to avoid the public contact as much as possible unless and until it is very much necessary. So yeah, so this was a good session that I liked actually. I was able to present here whatever the knowledge I have got in autonomous driving domain, and it was nice to talk with it was nice to present the session in front of you guys, and I got a nice opportunity to present the skills whatever I have got. So yeah, so with all, like I'd like to thank everyone, and I'd like to thank the management from TKM College of Engineering that they gave me this opportunity. Thank you very much.
Thank you, sir. So on behalf of Indian College of Engineering and as an coordinator, and also on behalf of participants, I sincerely thank for all your efforts and also for sharing a wonderful and very knowledgeable session. Thank you so much, sir. Thank you for being with us. Thank you, sir.
Thank you so much. Have a good day, everyone. Bye bye.
So, dear participants, so we need to take some photographs and also submitting in the Atal. So I request all the participants to switch on your video at least for a while so that I can take a snapshot as a document purpose. And the participants can you switch on the video for a while. Okay, thank you all. Thank you.
Thank you, sir.
Okay, I think we will start the next session by 11:45. So please join by 11:40. And feedback form and attendance form will be circulated by 12:15 or 12:30. Okay, thank you.